All right, good morning, Algebra 1 students. This is your lesson on absolute value inequalities. We're going to go over these notes. And before we get started, we need a quick review. So this is an absolute value inequality. That's what they look like. But first we have to remember what absolute value equations are. So this x minus 3 equals 5. We've done it before, but we want to just make sure we remember what it means. So what all that really says is when you have an absolute value equation, it means the distance inside the absolute value, or the distance from 0. So let's just write that down. Absolute value means distance from 0. The distance from 0 is, and then whatever comes next. And in this case, the absolute value of x minus 3 equals 5 means the distance inside that absolute value is equal to 5. So whatever makes that true. Let's look at that on the number line. So we have a number line here. It's from negative 10 to 10. The distance from 0 is 5. So normally we think of it this way. We think 1, 2, 3, 4, 5. So this is 5 away from 0, but isn't the other way 5 away from 0. 1, 2, 3, 4, 5. So really we have two values that are 5 away from 0. We have 5 and negative 5. And that's why when we do distance, or we do absolute value equations, we have two solutions. So in this case, we would write, I think we solve it down below here. Oops, nope, we gotta solve it right where it was. No, I already answered this one. So absolute value equations have two solutions, except when they have no solutions, and we'll talk about that a little later. So let's look at this. So we write it as x minus 3 equals 5, or x minus 3 equals negative 5, because if we go back to that picture on that number line, those two answers, those two numbers meet the requirement of the distance is 5. So the way we solve these then is we write our two equations after we've got the absolute value isolated. We get rid of the bars and we write the two equations. Distance was 5 or distance was negative 5. So then to simply solve that, add 3 to both sides. And then we end up with x could be 8, or x could be negative 5 plus 3 is negative 2. Either one of those would meet the requirement. So those are the two solutions for the absolute value of x minus 3 equals 5. There are the special case situations when there's no solution, and that is simply, why am I jumping around so much? That is simply when the absolute value is equal to a negative number, or the distance is negative. Well, that's not true. The distance from me to you is never negative, so that's false. So our answer is no solution. Now, let's turn that into some stuff that'll help us with absolute value inequalities. Again, remember, an absolute value inequality is an absolute value is less than or equal to, or less than, it's less than or equal to, or greater than or equal to. So we have the four possibilities right there. All right. I'm going to take those off because I don't want you to think I put a line underneath the less than. So in this equation, absolute value of x minus 3 is less than 5. This just says distance from 0 is less than 5. So if we look at our line and we go, well, we're at 0. We can go as far as, but not quite, 5 away. So we're going to go less than 5 away. So we're going to go to the 5, but not include it. And again, we can go the other direction, but not include it. So the distance from 0 and anywhere in between. So if I'm at -2, I'm less than 5 away. If I'm at +3, I'm less than 5 away from 0. So our solution looks like this. We're open at -5 and we're open at 5 because those are 5 away from 0. And we don't want to be that. We want to be less than 5. So now to solve this equation, anything that makes x minus 3 fall between -5 and 5 will give us our solutions. And so we're going to say x minus 3 is greater than -5. So anywhere that's higher than 5 and up to 0, so is greater than -5. And x minus 3 is less than +5. So it has to be in this range in between, so less than +5. And then again, we can go ahead and solve these by adding 3 to both sides. So that our final equation would read x minus 3, I'm sorry, we got rid of the minus. X is greater than -5 plus 3 is -2, and x is less than 8. As long as those values are true for x, we'll get that will fit and answer the equation or the inequality. We can write it in shorthand this way when it's an and statement. We can say -5 is less than x minus 3 is less than 5. That's not too important right now, but sometimes you'll see it this way and you'll need to be able to draw that onto a graph later. We'll come back to that. Okay, now, what if we turn that equation around though? So instead of saying x minus, the absolute value of x minus 3 is less than 5, we say this, x minus, the absolute value of x minus 3 is greater than 5. Well, all they're saying now is that the distance from 0 is greater than. I didn't leave myself enough room to write that in. Greater. Greater than 5. So now, if we look at our number line, right, and we're at 0, we can't be this close to 0. We have to be greater than 5 away. So we're going to put an open circle there. And so if I'm out here, I'm farther than 5 away, so that's true. But if I go the other direction from 0, if I go negative, then I'm going to put an open circle at -5 and go to the left. Anything out here is going to be greater than 5 away from 0, and anything out here to the right is going to be greater than 5 is 0. So anything, to solve our inequality, anything that makes x minus 3 fall outside of the space between -5 and 5 will make it true. So the way we write that is x minus 3 is less than, or going to the left of -5, and x minus 3 is greater than 5. And again, to solve that, we add 3 to both sides. And we get x is less than -2. Or, because when it's greater, we use the or symbol, x is greater than 8. That's our answer for that one. Now, a little memory trick to help you. When we see these symbols, less than or equal to, we know that it's an and statement. So we want you to think less than. Mark it a little small here. And then when you see these symbols, the greater than or equal to, think greater than. It's not correct spelling, but it's our memory trick to remember. So when it's less than or equal to, it's less than. That's going to be an and inequality. And when it's greater than or equal to, it's going to be great or. It's going to be an or statement. When it's and, we only take the places where it's happening on both lines. When it's or, we can take any place that it's happening on either line. I think that's it for the notes. We're going to give you some problems to try now. And then pause this and go back if you need to fill in any of the notes, or start on the practice problems and then call us over when you need some help.